Let's prove that the number 3 plus the square root of 7 is irrational. We'll use a proof by contradiction. Let's start by assuming the opposite of what we want to prove. Let's assume that 3 plus square root of 7 is rational. This means it can be written as a fraction p over q, where p and q are integers and q is not 0. Let's isolate the square root of 7. First, subtract 3 from both sides. This gives us square root of 7 equals p over q minus 3. To get rid of the fraction, multiply both sides by q. Now, let's square both sides to eliminate the square root. On the left side, we get 7q squared. On the right side, we get p minus 3q squared. Let's expand the right side. We get 7q squared equals p squared minus 6pq plus 9q squared. Subtract 7q squared from both sides. This gives us 0 equals p squared minus 6pq plus 2q squared. Let's rearrange this to standard form. P squared minus 6pq plus 2q squared equals 0. Here's the key insight. This equation must have integer solutions for p and q if our original assumption was correct. However, this is a quadratic equation in p, and we can solve it using the quadratic formula. Using the quadratic formula, we get p equals 3q plus, or minus q times the square root of 7. But this means p would be irrational unless q equals 0, which contradicts our assumption that q is not 0. Therefore, our original assumption must be wrong. We can conclude that 3 plus square root of 7 is indeed irrational. Let's summarize our proof. We assumed 3 plus square root of 7 was rational and could be written as p over q. Through algebraic manipulation, we showed this would lead to p being irrational when q is not 0, which contradicts our assumption. Therefore, 3 plus square root of 7 must be irrational. This is a classic example of proof by contradiction.